We move on to our perception of distance and depth. The first one is elevation. The elevation of objects above the horizon in our visual field is an important cue to their depth. Objects located higher in the field are farther away. Next is the interposition or partial occlusion. Interposition happens when objects are overlapping. The object that is partially covered by another one appears to be in the back. For example, the blue star is in front of the pink bar, while the yellow moon is not. We know that because the yellow moon is partially covered by the pink bar and the pink bar is partially covered by the blue star, we can perceive that the blue star is in front, the pink bar in the middle, and the yellow moon in the back. Next is the texture gradients. When we look at any textured surface, the elements comprising the texture appears smaller and denser as the distance increases. Texture gradients, together with linear perspective, are used a lot in artwork. As seen in the figure below, textural changes give us a strong cue about what we see. Differences in the way the lines are drawn give us different perceptions. Next is relative size. Relative size refers to a cue applied when two identical objects with different sizes are shown. The larger one is usually seen as being closer to the viewer than the smaller one. How about linear perspective? Linear perspective, often referred to only as perspective, is one of the most commonly used in two-dimensional artwork to give the perception of three dimensions. According to linear perspective, far objects are systematically smaller in size than nearer objects. Thus, parallel tracks appear to converge at a point called the vanishing point. An example of this is shown below. Next is aerial perspective or clearness. Aerial perspective refers to the difference in how clearly we can see objects that are far away and those that are near. Far objects are less clear because light rays passing through them travel through more of the atmosphere than light rays passing through nearer objects. Moreover, far objects have lower contrast with the background than do near objects. This is again because light rays lose more energy while traveling from far objects than they do from near objects. We move on to shading and lighting. Because the closest surface of an object to the light is brightest, we know from the pattern of shading and lighting about the depth and shape of an object. Artists have used this technique to illustrate depth in two-dimensional images. An example of such artworks is by Vermeer, shown below. He used light and shading to cue for depth. Wright of 1963 once said, "Our sensations of color are within us, and color cannot exist unless there is an observer to perceive them. Color does not exist, even in the chains of events between the retinal receptors and the visual cortex, but only when the information is finally interpreted in the consciousness of the observers." We see color in the objects around us because they absorb most of the wavelengths from the sun called white light, and they reflect only a particular wavelength into our eyes. For example, a red apple absorbs all but the 760 wavelength. Therefore, we see it as red in color. Objects that are white in color are objects that do not absorb any viewable wavelengths, while objects that are black absorb almost all viewable wavelengths. We know that the white light from the sun consists of many different wavelengths because of Newton's prism. Because of the prism's refraction, the white light is split into rays, emitting different colors of light, each of which has a different wavelength. The same phenomenon happens in nature, as we can see in rainbows. The dimensions of color. There are three psychological dimensions of color: hue, brightness, and saturation. What is hue? What we usually refer to as color is hue. We recognize a change in hue as color change. The physical dimension of hue is wavelength. What about brightness? This is the intensity of the stimulus. The more intense the light, the brighter the object appears. For example, an object's color appears brighter in a well-lit room than in a dark one. Lastly is the saturation. This is the amount of hue that we see in an object, how complex the light wave is. If the light is simple, for example, a sine wavelength, it is pure and therefore appears as very saturated. The pure color generated by a single wavelength is called monochromatic color. Now we move on to color psychology. Look at this picture. Does this picture make you warm? How about this? Do you feel cold? See this picture. Does this make you feel calm and relaxed? Certain colors can affect our mood. It can raise our blood pressure, increase our metabolism, and even cause anger. This is color psychology. Have you ever seen a black house or a black room? Maybe people wanted it because they want to show their style, their sophistication, power, elegance, and wealth. But how about the bad side? It can cause fear, anger, sadness, mourning, evil, and even death. Do you feel anxious in a blue room? Why do some people are addicted to it? Maybe because it's their way of showing harmony, loyalty, winter, cleanliness, skies and seas. But how about the negative side of it? It can cause depression, coldness. How about the color white? Does it affect your mood? It's to show purity, peace, cleanliness, simplicity, humility, marriage. But what about if you're irritated to seeing color white things? It can affect your mood, giving you coldness, cowardice, fearfulness, and imaginative, and surrender. What about brown? Brown can bring you calm, nature, richness, stability, and tradition. But for some people, it can have a negative perception like dirt, dullness, heaviness, poverty, and roughness.